Summit Preview 2019. We're excited you can join us today for Bob Pusateri's session, Dipping Your Toes in Azure Data Lake Basics for DBAs. This 24 hours of past consists of 24 consecutive live webinars delivered by expert speakers from the past community. This session will be recorded and posted online after the event. You will receive an email letting you know when this becomes available. My name is Eric, and I have a few introductory slides before I hand over the reins to Bob. If you require any technical assistance, please type your request in the question pane located on the right side of your screen, and someone will assist you. This question pane is also where you may ask any questions throughout the presentation. Feel free to enter your questions at any time, and once we get to the Q&A portion of the session, I'll read the questions out loud to Bob. You're able to zoom into the presentation content by using the zoom button located on the top of the presentation window. Please note that there will be a short evaluation at the end of the session, which will pop after the webinar ends in your web browser. Your feedback is really important for us for future events, so please take a moment to complete this. Our next scheduled past marathon is focused on career development and will take place on October 10th. Watch your inbox for an email when registration opens. Also, Past Summit 2019 will be happening on November 5th in Seattle, Washington. So head over to pastsummit.com and register today. This 24 Hours of Past session is presented by Bob Pusateri. Bob is a Microsoft Certified Master DBA and Systems Architect with over 10 years experience on SQL Server. His interests involve internal performance optimization and cloud technologies. He's an active member of both Chicago area past local groups as a community speaker and maintains a web presence through both Twitter at SQL Bob and his blog bobpusateri.com. And without further ado, here's Bob with Dipping Your Toes in Azure Data Lake Basics for DBAs. Bob, take it away.
All right, thank you very much for the introduction, Eric, and thank you everyone for joining me this morning or afternoon or evening, depending on where you are. As Eric said, this is Dipping Your Toes in Azure Data Lake Basics for DBAs. We're going to cover the very basics of Azure Data Lake. We have a brief agenda here of things we'll go through, but essentially the session is geared for those who are familiar with either SQL Server or another relational database system and are looking to expand their horizons and add Azure Data Lake technology to their skill set or toolbox. So at the core of Data Lake and any other data processing system, right, we have data. So let's talk about data for a second. Data is a bunch of things depending on your business and what you're doing it, right? You might have data about your customers or about your business, or your business itself might be data. Data has great value. It's valuable to you and your business, of course. That's what it's built on. Unfortunately, that means it also has value to others, right? Security is definitely a concern the last few years with high-profile breaches and whatnot. And because data has all this value, I think it's very fair to think of data as, in fact, a type of currency. In fact, some people say data is the new currency. So how do we store our currency? Well, kind of depends on how much and what we need to do with it, right? If you have a somewhat limited amount of currency, or more for one person, perhaps a wallet or a purse would be more appropriate for storing that amount. But when you get larger and larger amounts of currency, you really need to step up your game, both in terms of size and security. And then we end up with things like bank vaults. Right, sometimes we just need more. And like currency, I would argue the very same with data. So, obviously I said we're starting with SQL Server here, and SQL Server is a tremendous Swiss Army knife for dealing with data. It has lots of different capabilities. It's great at many things, and it's getting better all the time, right? Even with new features we have in SQL Server 2019, like big data clusters that are coming out. SQL Server is great at a lot of things, but it's still not one solution for everything. There is no one solution for everything, and that's not a dig on SQL Server at all, because and I'm sure many of you have built your careers on SQL Server over the past years or decades, but there's more tools out there than SQL Server, and sometimes we need something different. So that's what we're talking about today. Instead of SQL Server and a relational database, we're going to talk about Azure Data Lake instead. So what is Azure Data Lake? Azure Data Lake is an extremely scalable platform for housing all types of data for analysis. And the biggest takeaway from that is it is a storage system. It is not a database system. Data Lake has a lot of wonderful tools, has incredible scalability, but at the end of the day, it is really powerful, really expandable, but ultimately dumb storage. There's no processing power involved with Data Lake. You bring your own processing at a later step in the process. Data Lake is designed to be a tool that integrates with lots of different services for both input and output. You can put like literally any type of data you want in a data lake, whether it be streaming data from a web service, images, things from the web, floppy disks there in my demo if you have floppy disks, even though I hope you don't. And similarly, you can take things out of Data Lake and process them with virtually anything. You have many different options here. I show Databricks, we have Azure SQL Data Warehouse. You can visualize with Power BI. You can query with tools like Hive and other things. Data Lake's kind of this layer that sits in the middle and provides storage and security and accessibility to everything else. The idea is you have little to no transformation of your data to put data in Data Lake. You put the data in Data Lake essentially in its raw format, and you improve upon that data at a later step in the process. Azure Data Lake is performant. Like I said, it can scale linearly and infinitely on demand. It supports a whole bunch of different access patterns because we have all these different tools that it can work with. It provides security. It has row-based access control, both in terms of groups and principals. It has POSIX access control lists for securing individual items. It has management through REST APIs and scripting you can do, so you can work with it a whole bunch of different ways. And as I said already, Data Lake is kind of a bring your own engine approach. You're bringing something else to do the processing and make this data more useful, whether it's Databricks or Spark or Power BI or whatnot. There's lots of different things that will work with Azure Data Lake, but Azure Data Lake itself has no compute capability to do this processing for you. Data Lake is a great tool to have in your toolbox. It can save you considerable time depending on what you're doing, especially if you're using something like SQL Server integration services or maybe have a tiered archiving strategy. Data Lake can do that for you and perhaps cut out a lot of work, especially if you're spending time writing integration services packages to import data and make that data fit a specific shape when it goes into a system. If all you had to do was copy that data in its raw format into Data Lake and then deal with that work later, you could save yourself some time and some effort. Data Lake is more aligned towards data warehousing. It's more along informational analytical workloads for integrating systems as opposed to providing incredibly fast targeted access to an individual record or set of related records. So what goes in Azure Data Lake? Well, data, right? That's why it's called Data Lake. And so let's talk about that data a little more. There's what's known as the 4 V's of big data. They are volume, variety, velocity, and veracity. And more lately, I also hear value, which is kind of like the 5th V, which is essentially, are we creating value with these other 4 V's? Data in Data Lake is typically unstructured. And I should make the point of saying that all data has structure. But here, when I say structured data, I'm meaning already relational data. So we have structured relational data. We have semi-structured non-relational data, things like CSV files, JSON, XML. And then we have unstructured data like texts or JPEGs or PDFs. And again, all data has structure. So a JPEG image most certainly has a structure to it, but for purposes of this, we're going to say that's unstructured. Let's talk about the storage behind Data Lake. And so in the beginning with Azure, there was Azure Storage Accounts. There was Azure Blob Storage, right? Now known as Windows Azure Storage Blobs, or WASB. We're going to see quite a bit of 4-letter acronyms here. So we have Azure Blob Storage, and this is optimized for unstructured data, right? So files or images or video files or whatever you have. Azure Blob Storage is a completely flat structure. There is no folder tree in Azure Blob Storage. Now, if you've used Azure Blob Storage, you might know that yes, there are folders. You can create folders, but those folders don't really exist. Those folders are actually prepended to file names and exist more or less virtually. This is why, and again, if you've used Azure Blob Storage, you'd notice that if you delete all the files in a folder, the folder also disappears. That's because the folder was never there to begin with. The folder's presence is inferred based on the files being there. So when the files disappear, the virtual folder goes away as well. But the takeaway here is Azure Blob Storage is a flat structure. It's very low cost. It's cheaper than ADLS or Azure Data Lake storage, which we'll talk about in a moment. And it has tiering capacity, right? There's different levels of tiering in terms of both redundancy and performance. You can customize as you like, and your price will adjust accordingly. So the levels of redundancy in blob storage, there's 4 at the moment at least. There's LRS, locally redundant storage. This means you get multiple copies of your data in a single data center in Azure. There's what's called zone redundant storage, where you get your data goes in multiple data centers within a zone. And then there's multiple zones within a region. There's geo-redundant storage, which will replicate your data to a data center in another region. And then you have this second copy of your data sitting there in another region, and as soon as a disaster strikes the region, your primary region, Azure will essentially flip a switch and you will start reading from the other region, and that will become the primary. So you get redundancy across regions with geo-redundant storage, and then there's read access geo-redundant storage, which is the same as geo-redundant storage, except you can also read from the secondary copy at any time, whereas in geo-redundant storage you can't. So in read access geo-redundant storage, you get 2 endpoints. You have all these different options for redundancy, and you also have tiers in Azure Blob Storage. So there's 3 tiers. There's hot. This is for data that's accessed very frequently. You'd pay the most to store data in the hot tier, but your access costs are the lowest. There's cool, which is for less frequently accessed data. Storage is cheaper in the cool tier, and you'll pay a little more to access it each time. But if you have infrequently accessed data or less frequently accessed data, cool may be a more cost-effective solution. Cool also comes with a catch, which is you have to store data in it for a minimum of 30 days. If you delete it before the 30 days is up, you get billed as if it was there for 30 days. And then Archive, which is the newest of the tiers. Archive was introduced, I want to say, 2-3 years ago or so. This is for data that you ideally will very infrequently be accessing, or hopefully never. Perhaps data that you have to store for legal or compliance reasons, but don't plan on ever touching again. This data is extremely cheap in terms of storage, but you do pay more when you want to access it. This data is also very slow. You can't get your data right away if you need it out of the archive tier. It says slow to retrieve hours here. Azure actually just introduced expedited rehydrating of archives, so you can get things faster out of archive storage now if you pay more, but it still will not be anywhere near on par with accessing data in the hot or cool tier. So this is really data that you do not want to access frequently or often. It has a minimum 180-day storage policy, and this was Microsoft's answer to Amazon Glacier when it came out. So you have tiers in terms of both performance and redundancy in Azure Blob Storage, right? So then later on, Azure Data Lake Generation 1 came out, and this is that ADLS or Azure Data Lake storage I was talking about. Azure Data Lake Storage is a different type of resource in Azure. It was designed to be interoperable, designed to work with all major MPP, which is massive parallel processing platforms. It has the security features that we mentioned. It's got more security than Azure Blob Storage, just in terms of granularity, right? Azure Blob Storage is still extremely secure, but Azure Data Lake has more security tools available. was designed for performance, optimized for analytics type workloads, as I said, for different data warehouse type applications. There's no file size limit in Azure Data Lake storage, whereas there technically is in Azure Blob storage, but it's a very large number. I want to say like 4 terabytes per file, or 4.7 sticks out in my mind. But there is a limit at Azure Blob storage, however high it may be. There is no limit in Azure Data Lake Generation 1. And Azure Data Lake Generation 1 features a real, true hierarchical folder structure instead of the virtual structure that blob storage has. So then let's move up to the newest version, which is Azure Data Lake Generation 2, and this is known as ABFS, or the Azure Blob File System. Or sometimes it's called ADLS Gen 2 for Azure Data Lake Storage Generation 2. Currently supports most MPP and authentication schemes. Support is being added for this. The idea is for this to be on par with Azure Data Lake Generation 1, and it's getting closer and closer all the time. Azure Data Lake Gen 2 also has a hierarchical namespace. It has atomic file operations. It has the tiering features of Azure Blob Storage that we talked about in terms of performance and redundancy, and it's cheaper than Azure Data Lake Storage. And if you look here in this image on the slide here, this is a screenshot from the Azure portal. You'll see that in types of resources in Azure, Azure Data Lake Storage Generation 1 is actually a different type of resource, whereas Azure Data Lake Storage Generation 2 is a type of storage account. So it's kind of misleading if you're looking for it and you don't know where to find it, because Azure Data Lake Storage Generation 1 is an actual resource. You say, I want to create a new Azure Data Lake Storage Generation 1, whereas with a storage account, or with Azure Data Lake Generation 2, you create a storage account and then you install the Azure Data Lake Generation 2 file system on that storage account, and that is your ADLS Gen 2 resource. So they're different types, but that's because ADLS Gen 2 is built on top of Azure Blob Storage. So if we were to take these three things and kind of compare them here, we have object storage, which is the Azure Blob Storage we talked about, right? That has the features of the flat storage space. The data is a blob, it's scalable, it's very cost effective. We have ADLS Gen 1 with its true hierarchical storage space, its additional security, its atomic and metadata operations. Azure Data Lake Storage Generation 2 was an attempt to basically combine the best of both worlds of these into something. So you get the features of the file system storage that you really want with a data lake, but you also get the cost and the scale benefits of blob storage. So that's kind of how to compare and reconcile the three things. As far as the data we're putting in Azure Data Lake, let's talk a little bit about the different types of files, right? First off, we have text files, right? And everybody knows and loves text files for their advantages and or faults. They're human readable, they're very standardized, well supported. Pretty much anything I've ever worked with can support a text file or a CSV in some way, shape, or form. There's also JSON files, right? And JSON's also nice and human readable, a little more concise than XML. It supports complex nesting. Probably a downside of JSON files is your files can get really large without compression, but the same goes for text files, right? So these are the text formats that you could absolutely put in an Azure Data Lake. And you can put many types of files, and I'm just going over some of the main kinds. So if we want to step up our game a little bit over text files or JSONs, there's a format called Avro, and Avro is a two-part file format. So it has a binary portion that stores the data, but then the schema portion, which is in JSON. This supports schema evolution, so as your schema changes over time, the metadata that's in Avro can adjust for that, and you can have different records supporting different versions of your schema. Probably the biggest downside to Avro is it's not a pure text file. It does have a binary portion, so you need a viewer utility to read it, and there's lots of viewer utilities out there. There's even plugins for Visual Studio Code that can do it and stuff, but it's not something you can read just by opening up a text editor. If we want to go a little more advanced from Avro, we have the column formats, columnar file formats, and the two biggest players in this market are Parquet and Orc. Parquet was kind of designed by Cloudera and Twitter, and Orc was from Hortonworks and Facebook. These both support compression in a column format, not unlike SQL Server column store indexes. Same idea, not exact same implementation, obviously, but same general idea. So there's great compression in these. There's predicate pushdown. So if you're looking for certain records, you can scan the file for just certain records, as opposed to have to read the entire file in and figure out what matches. The file format can actually provide some advantages for you there. One of the downsides to this is that writes are slower because you're writing this column format that has to be calculated and compressed. But if you're going to be reading data a whole bunch of times over and over again, you would probably reap the benefits from looking at a column format like this. These are, better generally for analytical workloads, but as with any statement I'll make like that, nothing better predicts the performance of your workload than testing your workload. So I would definitely set up some sort of A/B test if you're looking at going to a columnar format, or if you're looking at using Azure Data Lake in general and saying, hey, can we get our job done better, faster, cheaper using these technologies instead? As I said, if you're querying data multiple times, this may provide great advantages for you. Or if you need column elimination because it is a column format, or predicate pushdown, you can reap benefits from both of these things. Also, when you're using a column format, you can definitely reduce or eliminate encoding issues. Sometimes with delimited text formats, you can run into issues with the encoding, right? Is it a UTF-8 encoded file? Is there a byte order mark on that file? Is whatever I'm reading it with expecting that byte order mark to be there? That can, source of many errors I've seen have evolved from things like that. If you're using one of these column formats, you can eliminate a lot of those issues. Moving on from files to where those files go, in Azure Data Lake, we have this concept called zones, and zones are a fancy word for folders. Organization is really your key to success with Azure Data Lake, as it is with many other things in life. If your data is not organized, you're probably going to have a harder time doing things. And especially the idea with Azure Data Lake is you want to make data accessible for self-service purposes, so organization is really important there. Some of the common zones you'll see across Azure Data Lake instances are zones like archive, raw, reference, curated, temp, and stage. You can also see other zones like test and prod in some environments. Some places also have subzones for things like subsystems and users. It's also quite possible to, create different data lakes for your dev and test and production environments, but some places will implement those as different zones instead. That is, somewhat safe to do because you can restrict access with zones with your access control list and the security features that we'll speak about in a little bit. But to go through some of these common zones, probably the first zone you would encounter is called raw, and this is where data is placed from a source system in its original state. So the idea is you put the data here in its original format and you really don't touch it. The idea is that this data is immutable, and in a perfect world, we would only append to this data as opposed to altering the data outright. Usually this is where data is sorted both by the source system and the schema, and often partitioned by date. This is so with that and with making it immutable, you can trace anything back to your raw data, right? That's the veracity of the 4 V's we talked about earlier, is what is the lineage of this data. I am big into genealogy and family history. That's one of my hobbies, and one of the biggest things with that along the same lines is that veracity. When you're researching ancestors, you will often find data that doesn't match up. I have relatives where I have 2 or 3 different sources claiming what their date of birth is, and they're all different. They don't agree. So when you're doing genealogy, one of the biggest things you do is you keep track of not only the facts you found or what you believe to be facts about an individual, but where those facts came from, because that can be important too. Kind of the same idea here with Azure Data Lake. We have conclusions and estimates and whatnot models perhaps that we're going to do downstream. We want to be able to trace that back to raw data from a source system at some point. So if someone ever says, that number doesn't look right, how did we arrive at that? Well, we could actually trace back to the system and say, well, here's the raw data that we calculated from. So that's the raw zone. Next would be the curated zone. This is where data is stored in more of a transformed state, similar to like a data warehouse or a data mart. or data mart, pardon me. This is where end users would be accessing the data, ideally for self-service. This is usually what the analytics is performed on. This is data that's been governed and subject to internal policies and whatever your organization might have. This is a very flexible zone because every organization will tend to use data differently. So your usage patterns and internal requirements and goals can very much determine what goes in this zone. But typically it's data marts, data that's going to be integrated with other systems at some point, perhaps sandbox for your data scientists so they can get at their data and do their magic that they're doing. That's the idea of the curated zone. There is a temp zone. And earlier we talked about the raw zone being immutable data, and that's ideal. But there comes times where the raw data can't be mutable. Maybe it's streaming in a way that we can't really do it in an immutable fashion. This is where the temp zone can really help, because what you can do is you can take data, stream it into the temp zone, and kind of like batch it and then put it in raw. That's what I see the temp zone used for a lot, for loads that arrive constantly, batch it together for analytical groups, and then place it in the raw zone. You can also use temp data to do things like calculate deltas, maybe your data that's coming in, you want to track change over time, so you have values in the temp zone that you compare your data to calculate that change over time. And then you can move data out of the temp zone to either other zones or just plain deleting it as your needs change or your process moves forward. And then we have the archive zone. The idea of the archive zone is this is data's last stop before it is either removed or moved to a different tier. So maybe this is the idea of that data you have to keep for compliance purposes, but you're never going to use, right? Maybe you don't touch data more than 7 years old, but you have to hang on to it anyway. This is the general idea of the archive zone. You can, of course, restrict access to the zone as you can any other zone. If you don't want it being utilized, you can make sure it's not utilized. You can use the tiering features of Azure Data Lake Generation 2 and move it to something like Azure Blob Archive Storage, where the data is there and it's safe, but it's stored incredibly cheaply. You can take advantage of features like that. This is the idea here, is this is kind of the data that's not in active use but needs to be kept otherwise. So a question I often get is, you just talked about these zones. How do we move the data between the zones? Well, there's a couple ways to do it. Azure Data Factory has tools that can help facilitate that movement, but the bigger idea here is you really don't move data between zones. You transform it and you create a new data set in a different zone. That is by far the more common pattern of use. But there are tools that could move the data between the zones. You could technically do it with Databricks or Oozie. Other MPP engines can do it. There's AZ Copy, which is just a copy utility in Azure. There's tools out there that can move data between the zones, but that's really not the pattern we're looking at here. I know it's easy to think of that, especially if you're coming from a SQL Server SSIS standpoint, like, oh, I have a table full of data. I'm going to now, copy this data to another table and perform some transformation on it. Whereas you could also, transform that data before writing it to the other table, which is kind of the idea we're getting at here with Data Lake. So we've talked about what you can store with Data Lake and how you can store it. How do we process the data, right? And this is where we kind of step outside of the Data Lake realm for a moment, but we're talking about the engines that will actually process the data that's stored in Data Lake. And there are many, many engines available, and this is by no means an exhaustive list, but we have Databricks, we have Azure SQL Data Warehouse, we have Hive, which is an older technology, I would not be my first choice if I was processing data. And then we have U-SQL, which is the language of Azure Data Lake Analytics, which is also a technology that I would not be my first choice at this point. If you're doing net new development, trying to utilize Azure Data Lake, I would go with something like Databricks or Azure SQL Data Warehouse before I started touching the technologies like the Hive or the U-SQL. So Azure Databricks, and this is an image I stole from Microsoft because it does a wonderful job of not only talking about Azure Databricks, but seeing how Azure Data Lake Storage kind of facilitates pipeline here. We have data coming in, we ingest with something like Azure Data Factory, or maybe Cosmos DB would be another example of something great for ingestion. We would store it off eventually in Azure Data Lake storage, where we can do explorations with Azure Data Explorer. We can use Databricks to do processing and training. We can serve that data up through Azure SQL Data Warehouse and then visualize with Power BI. Right, beautiful stack there. The idea is Azure Data Lake storage can facilitate the storage of the data between steps in a platform. And as it says here, Azure Databricks is an analytics platform based on Spark that's in the cloud. Incredibly powerful. There's also Azure SQL Data Warehouse, if anyone remembers SQL Parallel Data Warehouse Edition, which was a massive appliance, one or more racks. This is the cloud-based version of that is essentially SQL Server built out for massive parallel processing. Uses column storage and relational tables, and very familiar concepts if you're coming from a regular SQL Server environment. But this goes and it separates out the compute and the storage, so it makes it very easy to optimize and scale out for either performance or memory or whatever your needs will be. This can read everything from Azure Data Lake, can do work on data that's in there and import it and whatnot. We talked about Azure Data Lake Analytics, U-SQL. So U-SQL is a language, and it's kind of a combination of SQL and C#. You can execute it in the cloud in Azure Data Lake Analytics. You can actually execute it locally as well. You can for free, which is great. I have a slide on this later, but you can take data that you have locally and through Visual Studio create a U-SQL project and actually run U-SQL queries on that data and see exactly what it pronounced or what it produces. If you want to see some U-SQL syntax, this is some statements in U-SQL here. As you can see, there's some SQL Server or some T-SQL keywords you're probably familiar with. We have from and to and using in there. We're creating these objects called row sets, which is the at data set on the first line there. We're creating a row set where we're extracting 3 columns with those types from a tab delimited file there. So we're effectively selecting out of a file, out of a text file in this case, into this row set. And then our second statement is we're taking that data set and row set and we're outputting it to a different file. So this is kind of how, whereas as in T-SQL, we would just select these columns. Here in U-SQL, we're selecting the columns from a text file. At selection time, we're defining what type they are. Notice that we don't know ahead of time. We have to define that at selection time, and then we output it to another text file, which would go back into Data Lake or somewhere else to be processed further down the pipeline. That's kind of a very brief introduction of what U-SQL looks like and how it works. And U-SQL has all kinds of functions. Like I said, it's a hybrid of SQL and C#. So for example, like the toString method you would commonly use in C# development to express something as a string, that's valid U-SQL in this case too. And beyond U-SQL, we also have technologies like Hive, right? Hive is an ETL or query tool that designed to run on top of Hadoop. It has its own language, HQL, HiveQL, which is also very similar to SQL. So this is here an example of a HQL query. And you can see that looks even more like SQL. That was the idea, was you could take people who have relational database experience and get them writing queries in Hive against Hadoop or Azure Data Lake with very little learning curve from their existing SQL skills. So those are 4, but by not any means an exhaustive list of technologies you can access data in Azure Data Lake with. So let's talk about some design considerations, because you have a lot of freedom with design in Azure Data Lake, and as with many things in technology, that can either help you or hurt you. And if you don't know what you're doing, you're probably going to be learning some things the hard way. File naming is incredibly important. Again, remember that Azure Data Lake is a storage system, and as I said, it is a unintelligent storage system for a lot of purposes as well. We need to name files consistently. This will help with self-service, because the idea here is users will be pulling data out of Azure Data Lake on their own, hopefully without having to interrupt us too much so we can work on other things. We're obviously there to help, but the idea is to facilitate self-service. I prefer to use, and many other people do too, the data source and the date time in the name. So for example, if you had parking ticket data, maybe you would have a day's worth of parking ticket data named as, parking tickets with the date and then the time if you had multiple times per day, something like that. Something that's very identifiable as what we're looking at and when it comes from. Azure Data Lake also has the concept of partitioning, but it's very, very different from the partitioning you may be familiar with from a SQL Server background. The idea of partitioning in Data Lake is to make this data splittable. If we have text files or whatever format we're using, and we have one file per table maybe, or representing what we would with a table in a relational database, this can work, but as your size increases, it could become inefficient, depends on the engine you're accessing this data with and its limitations, and they're all different. So it may be advantageous to split up your data by date within a zone structure. But at the same time, some engines don't like thousands of files in a directory either. So if we had a parking ticket directory with one file per day, that may get inefficient in time. It may actually be more efficient to divide it up into maybe a year and a month folder and then the files like that. And you're limiting how many files are in a folder, because a lot of these engines, you point at a folder or a folder tree and say, go process what's in that folder tree. And it will then go ahead and try to determine how many resources to allocate, how many threads or workers, for lack of a better term, to allocate to that workload. And if it has a structure that it can spread across, it can perform much more efficiently. We want to avoid creating empty files or folders because those don't help anyone. They just get confusing. And you really don't want to mix file types or data types within the folder hierarchy. So if I had a folder structure here, like in this example line for parking tickets, and I had another folder structure for maybe, arrest records or something if I were a police department. You would not want to mix those in the same folder. You would want a different folder for arrest records and then going on that way. So as an example, again, of partitioning, we would take maybe like the raw zone that we're in, create a parking ticket zone, have a year, have a month, and then have the files themselves and have it divided that way. Partitioning kind of lends itself to another topic that's important in Azure Data Lake called splittability. Some file formats are splittable by your MPP engine, again, depending on what you're using. Some engines can actually split files into multiple segments and divide their workers amongst those files. Some engines support compression and can still split files that are compressed. Some can't. Some can only do it with multiple or with certain compression formats. This all varies by the engine you're using. So this is where you really need to check the documentation. If you're using Databricks, if you're using something else, read through the documentation and see what's supported. If the file format itself is unsplittable and the engine can't split these massive files up for you and reap performance benefits for you, this is where you would need to manage your partitions manually. And again, go with a directory structure maybe and try to balance file sizes when possible. If you can't do this, or if the engine can't do this for you, a great parallel is to think of what happens in SQL Server when you get a CX packet weight, right? You have a query across a really long table or set of tables. SQL Server is going to try to use the statistics it has to partition that across different worker threads. If those statistics are not accurate or up to date for whatever reason, that's a major cause of some workers getting more work than others, and now you have weights involved, CX packet weights, while everything catches up. You can run more or less into the same issue with MPP engines querying off of Azure Data Lake if the data is not divided in a way that the engine can handle it. Speaking about compression, as I said, compression can make file formats unsplittable. Some of the column formats we talked about actually have internal compression already, which is great. And sometimes you can actually recompress the column format on top of that compression with gzip. Again, it depends on your engine and what it supports. This is, again, something you would want to test. Are you actually receiving benefits from compression, both in terms of storage space saved and in terms of performance? If you're not, don't bother. Again, nothing will accurately predict the behavior or the size of your data than actually testing on your data with your processes. As with any other system, compression is a trade-off, right? There's no free lunch in computing. So if we're using compression, we may be saving ourselves storage space and memory and I/O and network and storage costs, whatnot, if we're paying for storage in a cloud environment or in a pay per byte environment. But we're going to pay with something, and that something we're going to pay with is CPU, right? We'll be utilizing more CPU time due to the extra effort involved in compressing and uncompressing this data as it is accessed. But CPU is frequently a available resource, so that usually doesn't make a difference. Again, this is something to test in your environment, just as I would tell anyone to test before deploying any level of compression in SQL Server, absolutely the same for Data Lake. Let's talk about some anti-patterns really quick. Probably the biggest one is the data swamp. This is where you end up with things like multiple file types within a folder. Maybe you have poor organization, there's no standard naming, governance, no data catalog. Again, one of the goals of Azure Data Lake is to make data available via self-service. And if there's no organization, if it's just a whole bunch of junk thrown into a junk drawer, self-service is not going to be simple, easy, or maybe even possible. And the idea is we want to encourage our users to use self-service and have pleasant experiences with it, whereas if they don't, it can get written off very quickly. Another anti-pattern is lots of small files. As I said, small files can add overhead and slow down MPP engines depending on how they're working, so you really want to make sure you have a reasonable number of files in a folder in a structure that your engine can work with well. And again, I've said this many times, but documentation is key. This is when you're rolling out Azure Data Lake and setting things up with an MPP engine, that is not a time to do the stereotypical thing and just ignore the instructions. You really want to check them out here. They will help you, I promise. So challenges with data lakes. So by themselves, a data lake doesn't really provide integrated views across an organization. Like I said, the data lake itself isn't doing that. The data lake is providing the data for self-service. It can be hard to guarantee the quality of data in a data lake. Again, that falls on your organization as well in terms of what is your governance structure, what is your processing structure. We just talked about data swamps and how it can become a dumping ground for unused data. This is where tiering really comes in hand. Metadata can really help. There's tools out there like Azure Data Catalog where you can actually write metadata for your data lake and have a guide published with this is where this data is. This is the format you will find it in. This is how to access it. Having good descriptive metadata can make all the difference in the world, depending, for any type of data at that matter. Governance can lead to problems, as I said. And data lakes, frankly, they're great for lots of different kinds of data. Relational data is not one of those types. If you have data that's already in a relational format, just flat out putting it in a data lake probably won't get you many advantages. If you're going to take data out of a relational format and put it into a data lake, have number one, a reason for doing so, and maybe this is data that's really old and not accessed anymore, not frequently accessed. We don't need the granular relational tools for it anymore, so we can justify putting it in a data lake. But if you're thinking to yourself, wow, we can get rid of relational databases and just use a data lake for everything, you're gonna have a miserable time with that and not get the results you want. Probably some of the biggest misconceptions I see with Azure Data Lake are that oh, it's a data lake, it's for IoT data. Well, that's a great use case. That's not at all the only use case. You can put way more than IoT data in a data lake. And you can also now access data in Azure Data Lake with relational databases too, right? Polybase can do this, big data clusters coming in 2019 will have this ability as well to actually query out to Azure Data Lake and pull data back in or link as an external table at that point. So you can touch it there as well and get it back into a relational engine if that's what you need. Let's talk about security really quick as we're moving on here. So Azure Data Lake Generation 1 had Azure Active Directory support. That's how you authenticated. It had user roles for account management. And then for data access, it had access control lists, right? These are the classic classic Unix style read, write, and execute permissions. That was controlling all the data access. The only roles that existed were for managing an account. You could set up ACLs, access control lists, on folders or individual files, but there was no inheritance. You could not inherit permissions from a parent object, so it didn't behave like a Windows file system, like an NTFS file system would, if that's what you're familiar with. There were also security groups that existed, so you could assign users to groups and grant rights via the groups, which is probably the most scalable way to do that. So if we're looking here at what you'd see in the portal in Azure Data Lake Generation 1, you would see this. This is the role assignments where you could add roles for account management, but then for actually managing the data itself, you got a nice interface of, like what I said, is classic Unix style file permissions. You have your users, can they read, write, or execute, etc. As far as bigger picture security in Azure Data Lake Generation 1, there was a firewall you could enable, and you could define a whitelist of address ranges that can access. Nothing outside that could. That's great. There's also encryption you could enable. You could enable encryption before data is written on disk. It supported TLS 1.2 for data in motion. That was Azure Data Lake Generation 1. Generation 2 built on this even more. So Generation 2 now has row-based access control for container level resources in Data Lake, and it has shared key and shared access signature authentication, so not just Azure Active Directory anymore. You can have shared keys for super user access and tokens for user permissions. It also includes limited inheritance. It works a little better. So when you create objects, it will inherit default permissions from its parent. So if a folder has default permissions and you create a file in a folder or an object in a folder, it would inherit the default permissions of the folder. But if those default permissions of the folder change, it will not cascade down later on. So it's still limited inheritance compared to what you may be familiar with in a file system. Security in Azure Data Lake Generation 2 kind of looks like this. So we now have users and groups and permissions we can grant. So we have more granularity, more freedom, ease for more complex security strategies. Let's talk about DBA topics really quick, right? Because we are coming from a SQL Server or a relational database background. So you may have questions, of how does a database technology translate into Azure Data Lake? Well, probably the biggest one is backups, and backups, there's actually not a great story for backups at the moment in Azure Data Lake, right? You could copy your data out of Azure Data Lake into another blob storage account. You can also manage your redundancy by, as I said, changing redundancy settings for your blob storage account that Azure Data Lake is based on. So you can have, geo-redundant storage and whatnot, and that will definitely protect you from certain types of disasters, but not all. Even geo-replication will not prevent you from the oops, I deleted that disaster, because that change would be replicated right away as well. So copying to a blob storage account is probably the best idea at the moment. And I keep holding out hope that they will add a feature that gives some sort of parity to this in the future. But when you're talking about extremely large data sets, as those that would often go in a data lake, obviously that gets a little harder. Other than backups, another question I get a lot about DBA stuff is, what about indexing? So as I've said several times before, Azure Data Lake is not a processing engine. It does not have any intelligence behind it, and in such, it does not provide any indexes on the data. It's a storage tool. It's not an indexing tool. U-SQL does have a create index statement, but literally all it does is reorder the data set. So it gives you the effect of setting a clustered index on something, but it is by no means an index. Usually if you want indexing, you're going to go to the file format itself instead. This is where those column formats come in handy, because you can take advantage of column indexes on the data supported by the file format. Also, if you really needed indexing, this is where I'd say you would turn to like an Azure SQL Data Warehouse or some other data warehousing platform. Those will provide the indexing you need for whatever your use case may be, but that will not come from Azure Data Lake itself. As far as development environments go, this really varies depending on what tool you're using. There's the Azure portal. If you're using something like Databricks, that's where you would do your setup of your environment there. There's Azure Storage Explorer for browsing the data. There's Visual Studio for putting together certain solutions. If you're writing U-SQL or whatever, you would write that in Visual Studio. But there's no one-stop shop development environment. There's no equivalent of SSMS for Azure Data Lake, and there shouldn't be, because Data Lake has no way of knowing what tools you're going to be accessing that data with now or in the future. So that's really dependent on the tool itself. If you wanted to get started today with Azure Data Lake, like a low barrier to entry project, I would consider is something like offloading archived or unused data from your data warehouse or your OLTP systems into Data Lake. Again, if it's data you're not accessing frequently, maybe it's not worth keeping in an expensive data warehouse or SQL Server system. Maybe you put it in Data Lake because you're accessing it so frequently. You could use Data Lake as a staging area for data warehouse loads, or you can have any net new development projects actually ingest their data through Data Lake. Now, because Data Lake is a cloud technology, people always want to know what's it cost. And the first answer, of course, is it depends. It varies heavily with what level of redundancy you're setting up with, where you're located. Prices vary by region, and they change all the time. So if you're watching this later on, you're probably going to see inaccurate prices. In fact, the numbers I give you here might be inaccurate as well. But as of right now, in the US North Central region, for Azure Data Lake Generation 1, you'd pay 3.9 cents per gigabyte per month. You would also pay an additional charge for read and write operations on top of the storage. Data transfers between regions or out of a region also apply, so you pay 8.7 cents per gigabyte per transfer. And of course, there's savings you can achieve through commitments, 1 or 3 year commitments, or monthly, or now you can pay monthly for your multi-year commitments. That's a new thing Azure rolled out like a week or so ago. Check the portal for the most current pricing info. If we looked at pricing for Azure Data Lake Generation 2, we now have multiple prices in play because we have that tiering we talked about. So we have hot, cold, and archive level storage, and we have different prices for each. But what you'll notice is the prices are generally cheaper in Azure Data Lake Generation 2. Not always the case, but certainly can be. But as your storage prices decrease, you'll see that it's 0.2 cents per gigabyte per month for archive storage. Your access prices greatly increase, right? It's $6.50 per 10,000 reads for that super cheap storage. So the storage itself gets cheaper, the access gets more expensive depending on your tier. Again, please check the Azure portal for current pricing info. This is no guarantee. If you'd like to try to play with this for free, you can, in fact, run U-SQL locally on your machine and just get a general idea of what can I do with a technology like U-SQL. And there's documentation on the Microsoft website for how to actually do that step by step. It's really nice. I have several resources here that I think are very helpful for Azure Data Lake. Particularly Melissa Coates has a lot of great blog posts on Azure Data Lake. There's some tutorials, some other posts, and that is everything I have. So at this point, if we have any questions, I'd be happy to entertain them while we have time.
Yeah, Bob, this is where I come in. We have had one question so far.
Okay.
From Gina Meronak. Maybe I should read it to you. You can see it also. She says, do you have an example of the user self-service data retrieval with Azure Data Lake? Are they downloading the files with Azure Storage Explorer or something else?
Well, so I guess, Gina, the example, I don't have one here, but the idea is, I mean, you could download the files, but the idea is your processing engine would go ahead and access those files itself. You would go ahead and write your query or your process in your processing tool, which would then have hooks into Data Lake and would know to go, scan this folder tree to find these applicable records that we're looking for is kind of the general pattern of how you would utilize something like that.
Yeah, thanks, Bob. So we have a couple more questions. Could you please share the resources page one more time?
Absolutely. Here, I will move right back to the resources page. I should also add that the slide deck is or will be available for download, so you can get all these slides in a PDF later if you'd like to read through it. And I believe the video from this will be posted a later date as well if you'd like to rewatch.
Okay, so we have a question from Beverly Dante. Can you use U-SQL with SQL Server only, or does it have to be used with Data Lake?
So U-SQL is a language of the Azure Data Lake analytics tool is what it is. So U-SQL will not work in SQL Server. SQL Server uses T-SQL. If you have an Azure Data Lake Generation 1 data lake and you're using Azure Data Lake Analytics as your processing tool, that is when you would use U-SQL. That's the native language of Azure Data Lake Analytics at this point.
Okay, so here's another one. How are we handling encryption? Says Mohammed Kokoi.
How are we handling encryption? Well, as I said, Azure Data Lake itself supports encryption. There's probably ways you could encrypt the data in the file before it goes into Azure Data Lake as well, if that's of particular concern to you. But there is encryption you can enable at the data lake level, and it will handle that for you.
Yeah, okay, thanks. So is there an on-premise equivalent of ADLS? Says Yogesh.
Is there an on-premise equivalent of ADLS? Officially, I mean, yes and no. There's not an equivalent in terms of a product. I would argue an on-premise equivalent would probably be not much different from a shared folder on a network drive somewhere. That's literally the idea here is if you have an analytical tool that's going to go out and run in the cloud and query data lake in the cloud or query data lake from an on-premise location, it'd be the same as any other tool running on your desktop computer or your server querying or scanning files in a local network folder.
Okay, wonderful. And just one more and we should wrap up.
Okay.
From Raul Schnelzer, how do you manage self-service authorization to zones for multiple groups of users / accounts?
So you can create groups of users. You can do that in Generation 1 or Generation 2, and then you can authorize them on folders or folder trees for different zones. So maybe there's a case where typically, the curated zone would probably be the thing you grant people the most access to. There's generally not as much reason for end users to see the raw zone. Sometimes you flat out can't show them the raw zone because it contains data that we don't expose elsewhere in the data lake. But you would grant, access to these resources through access control lists to whatever folders or trees we wanted to expose to users for self-service purposes.
Well, that about wraps it up. So I should finish the presentation. I think it was a wonderful presentation.
Thank you very much.
So we have a couple of lectures coming up next. Stay tuned for our next session. Do you know what's in your server's inventory with Alan White? Thank you all for attending. Hope to see you soon. This is 24 Hours of PaaS.
Thank you very much, everyone, for attending. Hope you have a wonderful day.
You too.